Hello, grade nines. So in this lesson, we are going to be looking at energy, which is going to be on page 11, I think, of your notes, page 10 or page 11. I want you to please bear in mind that there are different forms of energy. So the key take-home message for today is that energy cannot be created, cannot be destroyed. It just takes on different forms depending on the situation. And that is what we are going to teach you today. We're going to teach you that there are different types of energy, and that those different types of energy, they just get transferred or transformed into different types depending on the situation. That is the take-home message. So please make sure you're on the right page. And before we start energy, I'm going to go through all the calculations that you had to do for last time, and then we are going to start with the concept and showing you the difference between your potential energy and perhaps kinetic energy or chemical energy. Okay, so let's look back at our calculations that we had to do for in the last lesson or for homework. So if you look at question 2, it says a boy climbs stairs 3 meters high and 2 meters wide. This is very important that you read these questions very carefully, grade 9. This is very important. His mass is 70 kilograms. Calculate the work done in climbing the stairs. So what do we have here? We have the one section here, we've got everything we need. So I'm dividing this up into columns. Can you see I've got 3 columns here, and you guys should have the same. First column is what I have. And what do I want? I want the force and I want the work, because I need the force to calculate the work. First thing I'm going to do is I'm going to calculate the force. The force here, we're going to use our gravitational force or weight formula, which is Fg equals mg, to calculate the force, which is going to be applied to our work formula. For something like this, you could get half marks or you could get full marks for each calculation. But one thing is for sure is that we give you marks for your formulas. You could get half mark here or you could get a full mark here. So I could go half, half, and then I could go half here and then half here, just to break it up and give you as much chance as possible of getting marks. That could be worth 6 marks maybe. But can you see what was the trick here? We added a 2 meter wide value, which is irrelevant. You guys don't even need that for this type of calculation. The only thing you needed was the 3 meters wide, because the 3 meters was the distance that force was being applied on. It's the distance that is being applied on to calculate the work. The force is applied over a distance. That tells me how much work is done. Let's look at question 3. If Barry Allen, with a mass of 84 kilograms, runs up a flight of stairs 12 meters high in a time of 0.03 seconds, calculate the power. So this is also a very nice one. You need to calculate force, work, and power in one problem. So let's break that down again. We have our first column with everything we need. Then we have our second column for force, our third column for work, and unfortunately I had no space, so I had to write power at the bottom. So in the ideal situation, in a test or exam situation, I'll give you enough space to work this out. So let's have a look-see. We've got mass and we've got distance and time. We don't have power, and that is what the question actually wants at the end of the day. It wants the power, but to get power, I need work first. How do I get work? I need force first. So this is where we actually test your understanding of the different concepts. I work out my force because there's no net force, there's no acceleration. They didn't mention anything about acceleration here whatsoever. Okay, so I mentioned acceleration, then we would use F net. Here we're using Fg. Fg is going to be 823.2 newtons. That 823.2 is going to be applied to the work formula. And what is our distance? It's 12 meters. I'm going to have 9,878.4 joules. That is my work done. I take that value and I plug it into my power calculation, and therefore, and after that, I'm going to get a nice fat number. That's a lot of watts. okay? Because look at how much work he's doing. It's quite a lot of work in a very short amount of time. So the shorter the amount of time, the more work, the more power there is, guys. Okay, think about a car. If a car can go from 0 to 60 in 0.2 seconds or whatever those fancy cars can do, that means that they've got tremendous horsepower. I want you to bear that in mind. The shorter the amount of time and the greater the energy means that you are going to have a large value of, or a lot of watts, okay, or kilowatts even. I'm not going to tick this down, but it's the same concept as before. You get for formula, you get for subs, and you get for the final mark. Now, question number 4 is, black canary pushes a box along the floor by exerting a force of 15 newtons. The box moves a distance of 2 meters in a time of 0.9 seconds. Calculate the power. Once again, same thing. They want you to work out power. Power is the main thing that they're trying to work out here. So to get power, I need work first. To get work, I need force first. Luckily, I've got the force. They've given it to me, so I don't have to apply the force formula. So once again, divide your calculation space up, divide it up, and therefore you have got 50 newtons of force, you've got a distance of 2 meters, and you've got a time of 0.9 seconds. Plug and play, literally plug and play. Work out your work, 30 joules, apply that 30 joules in 0.9 seconds, you're going to get 33.33 watts. Once again, get a mark for formula, get a mark for substitution, get a mark for your final answer. Question 5 has got to do with Thor. I mean, who's not going to love that? And in this section, it gets a little bit, there's 2 sections to this. You've got question A and you've got question B. Be very careful, grade 9s, that you understand exactly what your teacher wants from you. What do they want in A? What do they want in B? Don't answer everything in one question. We'll deduct marks. That's not how it needs to be. You need to follow instructions. Following instructions is very, very important. Okay. So yeah, they want to know in A. They want to know what is the weight of your school bag. Okay, because Thor is lifting up your school bag. So let's see what exactly do I have here. If the weight means it's going to be Fg equals mg, so you have to manipulate that formula. And how am I going to break that down? I've got work, I have got distance, I don't have force. So you manipulate the formula and you are going to divide the work by your distance. Divide the work by distance. Therefore, the force is going to be 111.11 newtons. There we go. There's your answer. So we're not going to ask you always straightforward questions that ask the main physical quantity. We might flip things around and ask you to do a different type of question, or ask you for something for another value that it has not been given to you in the problem. B says, what is the mass of your school bag? So now you have to break down their weight even more. So now you use Fg equals mg. And you are going to divide that force by 9.8, because that's gravitational acceleration on Earth, and we're talking about Earth. And I'm going to get 11.34 kilograms. Question 6 asks, Selena is sitting 3 meters above the ground on the wall and is pulling a bag of stolen goods upwards at a rate of 100 joules per second. Okay, now it's giving you a little bit more information here. 100 joules per second. That means that power, guys, because it's the energy in the time, in the rate of time. So this is a tricky question. So I want you to highlight that section there where it says 100 joules per second. This is a very tricky one because they're actually telling you they're giving you the answer. Joules per second is power. That's what it is. Energy per time, across time. He does this in the time of 4 seconds. Calculate the force she must be exerting on the bag. So what I want you to do is, let's look on the side. The power has already been given to you by saying joules per second is equal to 100 watts. The time is 4 seconds. The distance is 3 meters. They want the force. That is the answer that they want. So let's divide this up and let's work out our work from our power formula. So if I manipulate my power formula, work is going to be power multiplied by time. So 100 times 4 is going to be 400 joules, because we've already got all that information. So now I have my work done. From that, I can further break it down, and I can say work is equal to force over distance, force multiplied by distance. So my work is 400. My distance is 3, but I don't have my force. So 400 divided by 3 gives me 133.33 newtons. Remember, you can give me up to 2 decimal places, and I will mark that correct. No more, and if you give me less, it's also not the end of the world. But 2 decimals is actually the best, please. 2 decimal places. Please make sure that you marked everything now. Make sure that you have gotten this right. If you are struggling with this section, please drop me a message, or or contact your Mr. Ginsberg, and he will help you out with any problem that you have here. But be very cognizant of how we have laid this out, of how we want you guys to calculate this and break down these problems to get to what the question is actually asking. So let's start with energy, which is right below the calculations that we've just done. And there's a little poster here that I found online that I thought really helped put everything into perspective. And you can make notes on this poster, and it can help you later on. And maybe just grab your examination pad out, or a little booklet, whatever you're using for yourself, and maybe just write these two things down as two different quantities. We have two types of energy that we are going to look at. Remember, energy is what makes matter move, makes an object move. So we've got kinetic energy, which is the energy of motion. So anything that moves, it's kinetic energy. Then we have potential energy. When you see the word potential energy, it means that energy is stored. It's stored. Like for biology, the energy is stored in the cell. It's the same thing, yeah. The energy is stored in the battery. Remember, for electricity, we had chemical energy that's stored in the battery. You have nuclear energy, which is the energy that's stored in atoms' nucleus. So in every atom, in that nucleus, there's energy stored. You have gravitational energy, which is the energy stored in an object's height. So the minute you see gravitational energy, you know that it's got to do with height. Because remember, what is gravity? Gravity pushes objects down, pushes matter down. So when you think of gravitational energy, it's got to do with how much energy is stored at a certain height. The higher you are, obviously, there's going to be more gravitational energy, and this is dependent on the mass as well of the object. And then elastic energy is the energy stored in elastic objects, or it's got to do with shape. It's the energy that is, think of a slinky. Let's think of a slinky. The energy that's required to compress that slinky as well as to stretch it out. That is elastic energy. Sorry. On the other side of the poster, you will see there's kinetic energy. Now, there's different types of movement, and I'm sure you guys will agree with me. There's mechanical energy, that is the motion of an object, so that would be within cars or in bicycles or anything that's mechanically based. So that's mechanical physics, so large physics. They're not like quantum physics, which is small physics. Electrical energy, which is the energy from the flow of electrical charge. What did we learn in electricity? That there's got an electrical charge is going to form an electrical field. An electrical field is electrical energy. Thermal energy is heat energy, is a vibrational movement of particles. So obviously, the hotter it is, particles are going to move faster within a container, within a space. Radiant energy is light energy, so photon energy. And then sound energy is a vibration transferred through an object in a wave to produce the sound. In grade 10, we go into a little bit more detail when it comes to light and sound. We look at electromagnetic waves as energy transfer. It's actually very cool, very interesting. For now, I want you guys to just break these two energies up, because we are going to go into this now, and I'm going to want you to know, or I'm going to want you to understand, that just because an object has potential energy doesn't mean that it won't have kinetic energy at some stage when that object begins moving. Okay, so let's start going through each section, and hopefully by the end of this lesson you'll have a good understanding of energy transfer. So grade nines, before we look at the two different types of energy that I've just explained, the kinetic and the potential energy, I want you guys to write in the definition for energy, which is the ability of an object to do work. Can you see how the work definition, work done definition, and the energy definition are closely related? And I want you to be very cognizant of this, and maybe actually draw a mind map for this entire section, and you can see how everything is interlinked and how they work together. Both kinetic and potential energy are measured in joules, and as well as work done is measured in joules. And at the bottom of the slide, I've written down that your energy cannot be created or destroyed. It can only be changed from one form to another. This is the law of conservation of energy, and you will need to know this. And we cover this later on in your book, and you need to write it in your book. For now, just fill in the definition, and then we'll carry on to the next section. Okay, so I am going to give you a little bit of an introduction to these two types of energy, which is potential energy and kinetic energy. And I want to actually go into a little bit more detail regarding it, because you're going to fill in on your page, you're going to fill in regarding potential and kinetic energy. The first one we're going to look at is potential energy. Now, gravitational potential energy uses the formula of, so EP is equal to mass multiplied by gravitational acceleration multiplied by height. So that in red is the formula for gravitational potential energy. Now, gravitational potential energy has got to do with the height. So what are the two things involved in here, guys? It's got to do with the object's mass and the height. So that energy is stored at that particular height. So the higher you are, and the more the more mass is involved in the object, the more energy is going to be stored at that height, at that particular height. That doesn't mean that that energy cannot be transferred or used as a kinetic energy later on. So let's look at these skiers over here. The blue skier has more gravitational potential because he's at a greater height. But when he starts moving, that particular potential energy is going to be transferred to kinetic energy because now he's moving. So whatever amount he has in joules, that's going to be used as kinetic energy to propel him down that particular slope. Let's look at the second image here. You can see it's a crane, and it's got an amount of it's got a mass on that crane. And if the mass of this container increases, its potential energy will also increase. Why? Because let's look at our formula. The formula tells you automatically there what's going to happen. The more the greater the mass, the greater the height, the more potential energy I'm going to have. The height of the container increases, potential energy also increases. So if you ever get stuck, I want you to look back at your formula. The formula is going to tell you exactly how that physical quantity behaves, or how that physical quantity is going to relate to another. So I have decided not to give you guys the elastic potential energy formula. It's a little bit more complicated, and you guys don't need to know that at grade 9 level. But elastic potential energy is that it's got to do with the work done to stretch or compress a spring or any object. Let's think of a bow and arrow, an archer with a bow and arrow. That person is stretching the bow and stretching the arrow. And as he or she stretches that arrow, that bow, that requires a certain amount of energy, a potential energy. Because why? The bow and the arrow is at a height, so there's potential energy there too. And the actual arrow and the bow are changing in shape. So if there's ever a change in shape, if there's ever compression involved, there's ever sort of stretching out that's involved, the chances are elastic potential energy is involved. So it's got to do with shape. And I want you to bear that in mind. It's got to do with shape, compression, and stretching out of an object. Okay, so on the opposite side of the spectrum, we looked at gravitational energy, that's stored energy in an object at a particular height, or an object that is compressible. Now we're looking at kinetic energy. So I've posted or I've pasted a picture here of a roller coaster. I'm sorry if the quality isn't great. It's the only one I could find. And you can see that there is a roller coaster that is moving up and down over a certain height. And here we're looking at how potential energy and kinetic energy are working together. So the higher the roller coaster is, the higher the potential energy. But then the kinetic energy is lower because it's not moving um, at its full capacity yet. Because in that moment, in that split second, the potential energy is greater than the kinetic energy. Then, when we're more at level ground or we lower, the potential energy is going to be lower and the kinetic energy is going to be higher, because now the roller coaster, or that little, I don't know, what would you call that thing that the people sit in, um, it's now moving at a greater speed. So therefore there is a greater kinetic energy. So can you see how there is, depending on the momentum, depending on how the object is moving, and there's many other things that are involved, and we're not going to get into that now, but the two are interlinked. Potential energy and kinetic energy are interlinked, and that's all you guys need to know at this stage. It has got to do with movement, whereas potential energy hasn't got to do with movement, it's got to do with height and shape. So those are static things. Height and shape are static, versus motion is dynamic. On page 10, there is a section there for the types of energies, just as I've just explained them to you. And I want you guys to fill these in. Now, I have abbreviated certain words because I wanted to finish writing in the memo. So please know that I'm going to go through each section and you need to write it in. For potential energy, it is the energy due to the position or shape. Okay, that's why we have elastic potential energy and we have gravitational potential energy. Elastic is more shape, and whereas gravitational is more position or height. So gravitational potential energy is due to the position, elastic potential energy is due to the shape. So please bear in mind that POT means potential and the EN means energy. Kinetic energy is the energy due to motion. So if we look at the two pictures you have in your book of Spider-Man, we've got bullets, moving cars, or a swinging Spider-Man as an example. And we use these examples later on. I'm going to ask you these questions, and that's why it's very important that you understand these concepts like well. You get it. So please, if you're stuck, please let me know. On page 11 are the energy formulas you need to know for grade 9. The first one is your potential energy level, potential energy formula, which is EP is equal to mgh. EP stands for potential energy, which is in joules, just like work done. Mass is in kilograms. Gravitational acceleration is 9.8 meters per second, -2, and height is in meters. Then kinetic energy is going to be half multiplied by mass multiplied by your speed or your velocity squared. That's how you're going to figure out your kinetic energy. So kinetic energy in joules, mass is in kilograms, velocity is for v, or speed, and it is meters per second. And we have to square it. You have to square it. Otherwise, you're not going to get the full answer. There are other types of energy besides that of potential kinetic energy. Those types are chemical potential energy, electrical energy, light, sound, or nuclear. Just like the poster we went through, you can fill in those answers based on that. So just pause this, make sure you fill in all your formulas, and you fill in your other types of energy, and then we will continue. As I said before, you guys, you need to be able to fill in the definition for the law of conservation of energy. Please fill that in now. It's the energy can be transferred from one form to another, but cannot be created and destroyed. Please write this in. It's very, very important. We test this later, because what did I say? Potential energy can become kinetic energy. Kinetic energy can become potential energy. They don't work in isolation. We've run out of a lot of, well, I've actually made a very, very long video. This video is very long. Hopefully I can upload it. I want you guys to complete page 12 and 13 of the calculations. The first calculation under Let's Practice a Few calculation on page 11, I've completed that for you. So please fill that in. It's got to do with kinetic energy. So it's asking there specifically, what is the kinetic energy of the lightsaber? And we divide it up again. Remember, in the science department, we're all obsessed with Star Wars, so be sure to see many, many Star Wars questions. This first column is going to be what I have. So I've got mass, and look at what I've done there. I've converted it to kilogram. Why, guys? Because you have to use the unit for the correct physical quantity. The velocity or the speed is 5 meters per second, and we want the kinetic energy. So we've got the mass, we've got the velocity. It's very, very easy to work this out because it's half. EK is half multiplied by mass multiplied by velocity squared. We do this first. That is my formula. This is my substitution. That is my final answer. So please write this in. Okay, then your work that you need to do in this lesson is you need to complete page 12 and page 13 of the calculations, and in the next lesson we will be going through all these answers. So use your time wisely, try and finish what you can so that you don't have homework. I hope everyone is happy with all of this and that they're enjoying the physics, and I hope you guys have a lovely day further.